Now in this example, we're going to be analyzing the graph of a polynomial function. We're really going to be putting together all of the things that we've looked at so far to this point. The x, y-intercepts, the end behavior, the turning points, the multiplicity, whether it touches or crosses the x-intercept, all that stuff put together into one graph to try to figure out what the graph will look like. All right, so in the example I have, I'm looking at x squared times x minus 3 times x minus 1. There is an 8-step process in your textbook on page 193. We're going to go through that 8-step process. The first of the 8 steps is to identify the end behavior. Okay, so the end behavior. Remember, the end behavior is the power function that represents the tails of the graph. Well, the power function is going to be your leading term. And here my leading term is found by taking all of the leading terms in each factor and multiplying them together. So I get x squared times x is x to the 4th with a 1 coefficient. So the end behavior is x to the 4th, and that tells us because it's an even power, the tails are going in the same direction, and because it's a positive coefficient, they're both pointing upward, just like a parabola that opens up. The only difference with an x to the 4th is that you can have some other wobbles in the middle. We just don't know where those occur, the turns, okay, or how many there are yet. So that's the end behavior. All right. The next step is to find the x and y intercepts. Let's start with the y. The y-intercept, remember, is what you get when you plug in 0. It's also the constant term when your polynomial is expanded. Now here, to find that constant term, all you really need to do is multiply all of the constant terms together in each of the factors, but remember that x is really x minus 0, right? So that factor could be seen as x minus 0 squared, okay? So when you multiply all of the constants, 0 times negative 3 times negative 1, the product is 0, right? In fact, what you'll find is that when you expand this, these two factors here, you'll have a constant of positive 3, but then you have to distribute the x squared to every term, and there will end up not being a constant term because everything's going to have at least an x squared. Okay, so the y-intercept is actually at 0, 0, 0. Okay, and that makes sense. If I plug in a 0, I get 0 times negative 3 times negative 1, which is 0. Okay, so that's your y-intercept. The x-intercepts. Well, remember, the x-intercepts correspond to the zeros of the graph. The zeros of the graph are 0, 3, and 1, always the opposite sign of what's in the parentheses. So the x-intercepts are going to be 0, 0, 3, 0, and 1, 0. So 3 x-intercepts. Okay. Next, we need to determine the multiplicity of each of those so that we can determine whether the graph touches or crosses the x-axis there. So at 0, 0, we see that it has a multiplicity of 2, which is even, right? So 0, 0 has an even multiplicity. And even multiplicity means that it's going to touch the graph, not cross it. Sorry, touch the x-axis. 3, 0. The 3 has a multiplicity of 1. Okay, so it's an odd multiplicity. And remember, with an odd multiplicity, we know the graph crosses the x-axis there. Same thing with the 1. The 1 has multiplicity of 1, and so because it is odd multiplicity, it's going to cross the x-axis as well. Okay. All right. So that gives us some information, very important information then. The fourth step, so that's the third step. So step one is here the end behavior. Step two really gets at the x and the y-intercepts. Step three gets at the multiplicity and whether it touches or crosses. Okay. Step four in our 8-step process is to use a graphing utility to graph the function. Okay, it's kind of cheating, but we're going to do that anyway. It does give us an idea of what's going on. I would like that you guys can get a pretty good feel for this without doing the graphing. But there are some things that we can't quite do yet. We can't actually find the turning points. We can determine how many turning points there could be. If you think about this graph is, or the power function x to the fourth, it's a degree 4 polynomial. So that means there's at most 3 turning points. Okay, so the graph, it could have 1 turning point to get both the tails going up. It could have 3 turning points, 1, 2, 3. There's not really any other option. Okay, and most likely it's going to have the 3 turning points. It can't have it can't have 2 turning points because 2 turning points would make the tails go in opposite directions. It also cannot have 0 turning points for the same reason. All right, so it has to have 1 or 2. Oh, I'm sorry, 1 or 3. Okay, so then let's go ahead and plot the graph. So I'm going to go to my y equals screen. Okay, so I'm in y equals now. And then I'm simply going to type in this function. So it's x squared, x squared, and then times the, and I'm going to put these in parentheses. It's parenthesis x minus 3, parenthesis, and open another one, x minus 1, close parenthesis. You should be able to see that. Then I'm going to go to zoom, and then standard, which is the 6th one down. And there you can see what that graph looks like. Now, it's not really clear what's going on near the origin here, so I might zoom in a little bit or restrict my window. So if I go to my window button, maybe in the x direction, instead of -10 to 10, this is the standard window, maybe I go -4 to 4. And in the y direction, I don't know, maybe I'll go -5 to 5. I'm kind of guessing, I'm not quite sure what I want there. Okay, well that looks good. I definitely don't want to go any higher on this minimum. I could shrink the negative x values in a little bit, and I could shrink down the positive y's. So maybe on the negative x, I'll make it -2 instead of 4, and on the positive y's, maybe I'll make it 3 instead of 5. So there's the window I'm going to use. Let's see if that one helps. Oops. Okay, I like that. Gives me a pretty good idea. Again, you can see where the 3 turning points are going to be. There's one down here, probably at the origin, one up here, and then one down farther on the right. Okay. Okay, so that gives us a good idea. Now, step 4 is just to plot that graph. Okay, graph on calculator. Okay, number 5 is to determine where those turning points are. Okay, well I can already tell you one of them is at the origin. The reason I know that is because at the origin the graph comes down and touches the x-axis but doesn't go through. If it touches, it has to go down, touch, and turn. That means one of those turning points is the origin. So the turning points, one of them right away is the origin, I can tell. Okay. The other 2 I'm not sure yet. And so I'm going to go to my calculate menu. We've seen this before. And we know that those turning points are local max and local mins. So I can go down to, let's go with the local max first. That'd be the fourth one down. We've seen this many times now. We're going to be looking for, what's it going to ask me here? Oh, for a left bound and then a right bound. So I just have to surround that local max with the cursor. Once on the left, hit enter. Once on the right, hit enter. Okay, and you can see my little arrows up here where I hit enter. Then it's asking me for a guess. So I just move that cursor back in between the arrows somewhere, hit enter, and you can see the maximum. It's not landing at a nice integer, that's okay. So one of them is going to be at, I'm going to round these off to maybe 3 places after the decimal. So 0.634, comma 0.348. Okay, so that's one of them. And then the other one is found again going to my calculate menu, and this time selecting the minimum. Hit enter, and we're looking for that point way down at the bottom here, so I need to move my cursor over. Again, I need a left bound, a right bound, and a guess. Select the left bound, select the right bound, give it a guess, and there's my minimum. Okay, so the minimum, it says, again, I'll do 3 digits after the decimal. It'll be 2.366, comma, negative 4.848. Okay. All right. Okay, so there's our turning points. And again, there are 3 of them, which makes sense because that's one less than the degree of the polynomial. Okay, number 6, the 6th thing that we need to do to analyze this graph is to use the information in the first 5 steps to draw a complete graph of the function. So we're actually going to sketch the graph in step 6. Okay. And we're going to draw it out, not just use our calculator for this. I'm going to squeeze it in over here on the right. Of course, I'm going to start by putting in my X-intercepts and Y-intercepts. So 0, 0 is on there. 1, 0, and 3, 0. Those are my 3 X-intercepts. The origin happens to also be the Y-intercept then. My graph is going to come down from the left. Oh, it doesn't go through though. I made that wrong. Okay, so it's got to come down from the left. It's got to touch at the origin. Then it comes up slightly and then goes back down through the point 1. And then it comes down. Now I've got to figure out how high to make that and how low to make that. So my maximum value, the height there, is at 0.348. So my scale would have to be 1, maybe going up that high. Then this would be just over a third, right? 0.348. That's the height of that point. The other point goes down to almost -5, so I got to get at least -5 in there. 1, 2, 3, 4. Extend this axis a little bit. 5, and so around, -0.48 or 4.8 roughly. I'm going to bring that across. And the x coordinate is 2.4 roughly, so 1, 2.4, no, 1, 2, yeah, 0.4, so it's hugging that other x-intercept pretty close there. Okay, So the graph goes down very steeply and then comes up even steeper. There it is, something like that. That almost looks vertical, but it's not supposed to be. I don't know if I can make that any nicer. Oof. But in a very short distance, it completes the rest of that. I'm trying too hard to make this look symmetrical, but it will not be symmetrical necessarily, right? It's, yeah, that minimum does not occur halfway between the intercepts, so probably trying too hard to make that look nice. Anyway, there it is. Okay, so there's my graph roughly, and I have these points on there. They're the local max and the local min. Okay, so that should be everything. Now, the 7th and 8th steps deal with the graph themselves. Step 7 says find the domain and the range. Okay, so in step 7, the domain. Well, we know what the domain is for all polynomials. I don't even need the graph for this one. It's all real numbers, right? These arrows, the tails, go left and right indefinitely. So all real numbers will be the domain. And the range, well, the range on this one starts at the low point, the absolute min, which would be our negative 4.848. And goes up to infinity, right? Remember, the range is the y values, your vertical values of the graph. All right. Now, finally, part 8. Let's see if I can squeeze this in the bottom. It says use the graph to determine where the function is increasing and where it is decreasing. Okay. So the increasing portion. Okay. There are two places on this graph, two intervals where the graph is increasing. One is from 0 to the local max, one is from the local min to infinity. Okay? So I need the x values for these intervals. So we're going to go from 0 to the x value of our local max, which is 0.634. So my increasing interval runs from 0 to 0.634. Remember, we include the endpoints on those. And the increase also occurs from the local min, which is 2.366, and runs over to infinity from there. Okay? Never include the infinity, but include the rest. So that's our interval for increasing. Now for decreasing, there are again two of them. I am running out of space here, so I'm going to get rid of the Y-intercept because that's duplicated on the X-intercept anyway. 8. I'll put 8 continued, C-O-N-T. And we're going to finish that off. So the decreasing portion, the graph is decreasing in the x direction from negative infinity over to 0. Negative infinity to 0. And then from the max to the min, the local max to the local min. So that would be in the x direction, it'd be the 0.634 over to 2.366. Okay? And so there you have it, 2 intervals of increasing, 2 intervals of decreasing. And that gives us really everything at this point that we can find out about the graph. But that's pretty good information. It's a lot of detail. It gets you a pretty complete graph. And of course you do get some of the information from the calculator, but that's okay. It still works out for us and completes what we need to of the graph at this point.